Okay, hi, how you doing? We're going to talk about exponential laws here that we're going to combine the product and the power law here now. So first thing we're going to talk about here is that if you need to understand these two concepts separately before we start to combine them, because it's just going to make it more confusing for you that if you don't understand them by themselves. So power law states, okay, in prior videos, power law states that what you have on the outside of a group, so if you take an exponent and you put it on the outside of the group, then any exponent on the inside becomes a multiple of that exponent on the outside. Okay? The product law basically states that if you have some like bases that have different exponents, same exponent, doesn't matter. Point being is that if you have like bases that are connected through multiplication, then you can add their exponents. And the only way that you can do it is through that multiplication. So, why is it that I have PEMDAS written over here? Well, the reason I have written PEMDAS over there is because if I begin to combine the product law with the power law, the important thing to note here is that I am combining a multiplication process with an addition process. And what's very, very important here is that you still must follow PEMDAS. And PEMDAS says that anything with a multiplication property must be done first before the addition property is taken care of. So, when I combine these two properties, if I want to combine them, remember, okay, the thing that's important here to remember is that there's going to have to be a multiplication. Meaning if I want to combine this group that has the power law on it with these groups that have the product law being applied to them, then these two must be connected through multiplication. If they were connected through addition, then there was nothing that I could do with this power law and this product law. I could just simplify them by themselves as their own right, as their own term. But if I'm going to combine them, there has to be multiplication in between them. And more often than not, you're not going to see this little multiplication dot in between them. What you'll see is a bunch of back-to-back parentheses. So the goal here is to pick out your power laws first. And the reason you want to pick out your power laws first is because they involve the multiplication property. So the very first things that I'm going to do then is that I'm going to go ahead and I'm going to simplify this power law. And remember how the power law states that if you have any exponent on the outside of a group, okay, then all the exponents on the inside become a multiple of that exponent. So, things we need to pick out here very quickly, that this is 2x cubed y, that group raised to the third power. So the things you need to pick out are what are your exponents. And just because there's only a 3 written there, it doesn't mean that the other values don't have exponents. The 2 has an exponent. Remember that this coefficient is not connected with that x exponentially, okay? They're connected through a multiplication, but exponentially they're not connected. So the 3, okay, is going to multiply this 2, which has an exponent of a 1, and the y has an exponent of 1 there as well. So I'm going to go ahead and rewrite this. 1 as a multiple of 3 is 3, so this is 2 to the third power. 3 as a multiple of 3 is 9, so that's x to the 9. And 1 as a multiple of 3 we just talked about is 3. So this now rewritten, okay, is 2 cubed x to the 9 y cubed times, okay. Now if you like to, you could have put this in parentheses and gotten rid of this dot, or some people like to see that. Another thing that I want to point out to you is just because the product law is written with back-to-back parentheses, you don't have to write it that way. You could write it out as using the product dot notation. So I'm going to do that here. So this becomes 3y squared times x cubed y. And I don't have any exponent on the outside, so I don't need to worry about multiplying anything. So now what I have here is that all of this strand is connected by multiplication. So what I'm going to do is remember that the most important thing here now is that we always multiply the coefficients first. Anything that's not an exponent, that is a number, we're going to go ahead and multiply together. So right here I have 2 to the third power. 2 to the third power is really 8, okay? So this I could simplify even farther if I wanted to the next step and say that 2/3, which is 2 times 2, times 2, which is 8. So I could say that this is 8x to the 9, y cubed, times 3y squared times x cubed y. So this is where I would now do 8 times 3, and I always do this first. Always, always, always I take care of the coefficients first. I don't even worry about the variables. I don't worry about the exponents. I worry about the 8 and the 3, multiply them together, you get 24. Now I start to say, okay, what are my bases? And my bases are an x and a y. So I'm going to write them back out. So I'm going to have an x and y in my final answer. And whatever their exponents are is what they're going to be. So I have a 9 and a 3. 9 and a 3 make 12. So this is 24x to the 12. And then I have a y, so y has a 3. That one has a 2, so 3 and 2 make 5. And that one has a 1, so that makes 6. Okay? So essentially what I've just done here is I've taken a law that had a power law, turned it into its new term, okay, after applying the power law, and then this is all just one big product law. So again, the important thing to remember out of this is that you must do the multiplication property first, which is a power law has the multiplication property, and the product law has the addition property attached to it. So the final answer to this one is 24x to the 12th, y to the 6th, and there's nothing more that I can do with that. So I hope that helps in understanding when you're combining these laws together to help you do it when you work.